Hello guys, welcome to your Python programming tutorial videos, and in this video we are going to be looking at the Python assignment operators. I'm going to be showing you a lot of examples because assignment operators are one of the most common operators used every day in Python. We use them when we are assigning values to identifiers, but operators can become sometimes very complex. We are going to see sequence assignment operators and the rest. Now let's go directly to the video so we can do some brief literature first. Now, assignment operators are binary operators. We have learned about binary operators in some past videos. They have two operands, that's a left operand and right operand. Now, assignment operators will assign the value in the right operand to the value in the left operand. All right, so let's say the right operand to the left operand. Let's just say like that. Now, assignment operators operate from right to left. It means they operate from right to left. It's right to left, not left to right. Now, that is they assign values of the right operand to the left operand, the identifier or variable name. Usually, the left operand is usually an L value. That's they call it an L value. Sometimes in some programming languages, it's usually an identifier. As we have seen in previous examples, the assignment operators can take various forms as shown below. We have a basic form, we have a tuple assignment, we have a list assignment, we have a sequence assignment, which is generalized. We have an extended sequence unpacking. We have multiple target assignment, and we have augmented assignment. We are going to be looking at all that, so don't worry about that. Now, basic assignments is this. Now, we have seen this in many examples. A equals to 30.5, that's a float, and var1 equals to 3.4j, that's a complex. List 1 equals to some list. We have 3 items, I think 4 items. Then we have a set. Now, this is a set. We have looked at sets in previous video. We have looked at this. I think, yeah, we have looked at complex numbers here. So now, following up, we see we can print those values out. So this is normal basic assignment, which you do every day and which we have been doing in our past videos. Now we print those values out, and yeah, all right. Now let's move to shorthand or augmented assignment. Now, shorthand or augmented assignment is like doing an assignment and assigning the result to the same left hand variable. Now you have a left and right operand, and you do an operation with a left and right operand, and then you assign the result back to the left operand. So now here, for example, we have var1 equals to 10. Now to add 30 to var1, we normally say var1 equals to var1 plus 30. So we are using the left operand, we are assigning the result of the operation back to the left operand. In that case, we can use what we call a shorthand operator. So this is going to be saying add and assign back. So that's what to say. Now here, var1 plus equals to 30 means add 30 to var1 and assign back to var1. Now var1 minus equals to 10 is the same as saying var1 equals to var1 minus 10. You see some repetition here, so it's like a shortcut. That's why we call it a shorthand operator. Now it's saying var1 minus equals to 10 means var1, subtract 10 from var1, that's var1 minus 10, and save the result back in var1 or assign the result back to var1. Now let's look below. Is a list of the main augmented operators. Now we have add and assign, like plus equals to, we have minus equals to, we have multiplication equals to multiply, and that's multiply left operand, right operand, assign the value back to left operand. Here, divide left operand by the right operand, assign the value back to left operand. Here, calculate the modulus of left and right operand, assign the value back to left operand. Here, divide the left by right operand, assign the value back to left operand. And here we have find the exponent of left operand to the value right operand, assign the value back to left operand, and carry the and bitwise operator. We are going to look at this when we look at bitwise operator. Or equal to, here we have exclusive or equal to, here we have shift right equals to, shift left equals to. Now let's look at some examples. Here we have a equals to 2, for example. Here we can say a minus equals to 5 means subtract 5 from a and assign the value back to a. So it's the same as saying a equals to a minus 5. We print out that value. As you can see, the initial value is 2. When we subtract 5, it becomes -3. Now b equals to 4.5. We can also do the same thing. We add b plus equals to 15. It's the same as saying b equals to b plus 15. So do calculate b plus 15 or evaluate b plus 15, assign the value back to b. All right. Now we can see those stuff here. So you see the new value of b here is 19.5. We also have for c and g. Now we say c times equals to g. We are saying multiply c by g, assign the value back to c. That's the same thing here. So c is equals to 12. When you multiply c by g, which is equals to 10, you have 120. Assign the value back to c. C becomes 120. All right, here we have d. Now we say divide d by e and assign the value back to d. So it's the same as saying d equals to d divided by e. Now what we have here, when we divide d by e, we have 0.4. Assign the value back to d. So d now is equals to 0.4. We also have e. Now we are saying floor divide means discard the fractional part, or not just discard but round up. So we have e divided by equals to 5, which means e equals to e floor divided by 5. So we are going to have 4.5, and when we divide it, we are going to have 0. So let's see, we have e. So we have e is floor divide equals to 5. So we have 0, I think 0.0, because 4.5, I think we have 0. All right, so let's see this. All right, floor divide. Okay, let's move forward. So here we have modulus. So find the modulus of f divided by g. That's f modulo g. Assign the value back to f. So f modulo g will, if you divide 130 by 10, you're going to have a remainder of 2, and we'll assign that remainder back to f. So f is equals to 2, and here we have g equals to 10, g raised to the power 2, which is g exponential 2, or raised to the power 2. Assign the value back to g. So 10 raised to the power 2 is 100. Assign the value back to g. G becomes 100. All right, so let's look at multiple assignment. Now multiple assignment is similar. It's similar to what we have been doing. We just say var1 equals to var2 equals to var3. Now, instead of saying var1 equals to 10, var2 equals to 10, var3 equals to 10, what we do is that we say var1 equals to var2 equals to var3. So each of them are going to assign this value. 10 is going to become var3 to be assigned to var3. var2 is going to be assigned to the value of var3, which is now 10, and var2 is going to be assigned, var1 is going to be assigned to the value of var2, which is now 10. So we can print this, and you're going to see the output, is 10, 10, 10, 10. All right, now we have sequence assignment. Now, this is a tuple, like I told you. You can omit the braces of a tuple. Now, AB equals to 10, 20.10. A is going to be equals to 10, B is equals to be 20.10. Now, here we have name, age, gender equals to Emmanuel 40, male. So name is going to be the Emmanuel, age equals to be 40, and gender, male. Now, you can consider this to be tuples. You can put in the braces at the end, at the start and end. And here we are going to see the example. So as you can see, A, B, here we have them. Now we can use the tuple and list assignment. You can see this was a tuple. A tuple can be written by omitting the braces or not. So here we have a tuple equal to another tuple. So name will be David, age will be 43, country Nigeria. Here name 2 will be equals to Marvis. Here is a list assignment. So we have, as you can see, name 2 because to Marvis, age 2 because 25, country 2 because to Nigeria. As you can see the outputs here. Now extended assignment, here we have a sequence which is 1, 2, 3, 4. Now we say A, B, C, D equals to that sequence. Now it's going to be destructured or like assigned. So A now is going to take 1, B 2, C 3, D 4. Now here we have E is equal to the sequence it. E, F, G equals to the sequence it. So E will be E, F will be A, G will be T, as you can see from the output here. E, F, G, E, A, T. 1, 2, 3, 4 for this one up. So here we have a more complex equation. Here we have A, B, C. Now C will take word. Now A here will take H, and B here will take I. So don't worry if you don't understand this complex one. You may never even use it in your whole Python career, but it's good to know they exist. So A here will be H, B here will be I, and then C will be word. Now in this case here we have a more complex one. Here this one is going to collect, this star C is going to collect the rest of the parameters. So for example, here A is going to be 1, B is going to be 2. Now C is going to be 2, 3, 4, 5, 6. It's going to collect all the rest of the items in the sequence, while D is going to be word, as you see. So as you can see, A is 1, B is 2, C is the least, 3, 4, 5, 6, and then we have now D, which is word. All right, so I just wanted to show you. Now swapping variables. Now because of this, because of the presence of sequence assignment, you can swap values in Python using one line. Now we have using on a single line. For example, we have num1 equals to 10, num2 equals to 20. Now you can see, just to swap them, you just use this kind of assignment where you say num1, num2 equals to num2, num1. So num2 become num1, and num1 will become num2, and num2 become num1. So as you can see, we swap. It was first 10, 20. Now we swap those variables. Num1 equals to 20, num2 equal to 10. All right, that was a long video on Python, let's say Python assignment operators. Hope you enjoyed and hope you learned a lot, and hope you saw assignment operators can also become complex when you deal with sequence assignment. All right, thank you, and see you in the next video. Have a nice day.